We are now going to check problems 7 through 12 on our review. I hope that you have finished these problems first and you're checking your answers with mine. In problem number 7, we're looking at reading this problem and pulling out that it's asking me 3 out of 4. And I want to know what percent is the same as the fraction 3 out of 4. If we get this benchmark fraction to 100, we would say that it is 75%. So now I'm looking at what is shaded 75%. All these are pretty dark and black, so a strategy is to count what is not shaded, and then you want to find out what is shaded. And if I'm looking at 75%, that is more than half. So I'm going to eliminate some of these pictures that are not more than half. I would eliminate A. I would eliminate C. And then I would start counting. If I want 75%, that also tells me of one of these bars that is a group of 10, only 5 out of the 10 would be shaded. This one actually has true groups of 10, which is 20, plus 5 more. If I take that away from 100, I'm left with my 75. So B is our best answer that represents 75%. In problem number 8, it's asking me to write a fraction for 80%. So which fraction would be the same? Let's take our 80%, since all percentages are based on 100. I've made it a fraction out of 100, and now all I need to do is reduce. One strategy that we could do is about a 0. That's like dividing through by 10. But this is still not reduced. I need to reduce it again. I'm just going to divide by 2 and divide by 2, and I'm going to get 4 out of 5, and I have that reduced fraction. And this is a benchmark as well, so we can know it as a benchmark. In problem number 9, it's asking me to read this information and answer 3 questions. So as I read that Josh has a bag of marbles, he has 50 marbles in a bag. 25 are red, 10 are yellow, and 15 are blue. And I want to change each of these to a percentage. I want to know what percent of the set of the 50 marbles are red. Up here it says 25 out of 50, and that's a fraction. I'm going to look at yellow. It's 10 out of 50 are yellow. And the blue is 15 of the 50 are yellow. Now my strategy here, all percentages are based on 100, so if I can get a fraction out of 100, my percent would be sitting on top. So I want to make all of these fractions equivalent to 100. On red, we're going to multiply by 2. On the bottom, we multiply by 2 on the top, and we get 50%, because 25 out of 50 is 50%. Now I want to multiply 50 times 2, and we get 20% for yellow. So yellow is 20%. And again, 50 to 100 is multiplying by 2. 15 times 2 is 30. So our blue is 30%. Now check your work. All of these percentages here should add up to 100%. 50 plus 20 is 70, plus 30 is 100%. So you have a self-check built in. On problem number 10, it's asking me which one of these all have the same value. So there's more than one. There are actually 4 that have the same value. I see fractions, percentages, I see decimals, I see fractions, and more decimals. Well, I'm going to change these so that they look somewhat the same. I want to change all of these so they have a fraction out of 100 so that I can compare. If I take 3/20 and make it a fraction out of 100, which will give me a percent, I'm going to multiply by 5, and I get 15 hundredths. 15% is out of 100, So there is 1,500. So right now I have two that are the same. If I do my 15% and do Dr. Pepper, because I want to get it to 100, which is a percentage, I would have 15% as well. If I take 1 out of 15 and get it to 100, do I get 15 on the top? In other words, I would say 15, to get 15 on the top, I would have to multiply through by 15. Is 15 times 15 100? No, that does not work, so I'm going to be crossing this one out. I'm going to take 6 out of 40. I notice that I want to get to 100, but I don't think 40 can go to 100, so I'm going to reduce this down, and I'm just going to cut it in half and get 3 out of 20, because I divided by 2 on the top, divided by 2 on the bottom, and this looks exactly like my first problem, which does go to 100, and I get 15. Now let's talk about this 1.5. I want 1500s, 15%. If I do Dr. Pepper and move it from a decimal to a percent, I would move it once, move it twice, but I would have to fill in a circle. Are we talking about 150? And that answer is no. So we're going to cross that out. So I have 1, 2, 3, 4 representation, fraction, decimal, and percent that are all the same value. Let's look at problem number 11. It's asking me to compare 8 students, and that is 20% of the class, and I want to know what the total number of students would be. So when I set up my ratio table, I know that I have 100 and a percent symbol sitting on top. My top number is going to be my part, and my bottom number is going to be my whole, or what we consider to be the total. Right now, the information that I'm given is the 20%, and this 8, is that all my students or part of my students? It's part, because it's the part of students who are absent. So we want to put 8 here, which means I'm looking for the total or the whole. So now I want to match this to see if we have the same information. I have 20 over 100, 8 over x. I have 20 over 100, 8 over x. Does it matter which set came first? No. So I'm going to check that off, that I think it's correct. I have x over 8, but if I had the 8 on the bottom, I would need the 20 to be on the bottom and side by side. So this one is not going to work because my 20 and my 8 are crisscrossed. Let's check this one. I have my x over 8, which I can read, x over 8, but the x has to be in line with the 100, and it's crisscrossed, so that one does not work. And again, I can look at the 8 to x, but with the x, I need the 100 to be with the x, and it's not, so that makes it wrong. So A is going to be my best answer that would represent it. My other strategy that I can do here is actually solve it and break this down. If I zip out this 0, what can I do to 2 to get to 8? And that's times 4. So what is 10 times 4? And x would equal 40. If I plugged in 40 here, would I get the same number? If I plugged in 40, would that be true? If I plugged in 40, would I get that number? And if I plugged in 40? And none of these are true except for this one that actually works. Let's look at problem number 12 now. We bought $80 watch, and it's 25% off. If we get to take something off, we're going to find the discount first, and then we'll be able to find out how much we get to take off. And again, there's several different strategies I could use. If I did a ratio table, I have my part, I have my total, I have my percent over 100. The information that it gave me was 25%, and this $80 is the whole watch. So I'm going to put this total 80 down here. Now I'm going to have to do some reducing first in order to build back. This actually reduces down to 1/4, and now if I go back, what can I multiply by 4 to get to 80? and that's going to be times 20. So that's going to be times 20, and we get 20 here. And what is it asking me? The amount of money that I get to take off. And this 20 is representing $20 is my discount that I get to take off because it's a discount. Now, you could have done this another way. You could have said 80 times 0.25, and you still would have gotten this as a number, but you would still need to count behind 2 places to get your $20 and get the same amount. And just in the next video, we'll go over the next set of questions. Please make sure you've done it before you check it with me.